Once again, molweni everyone, esesengemu chawana. Okay, now this is the theorem of a binomial series. So this is how you state a theorem of a binomial series. It's clearly stated here. It states that now if we have 1 plus ax all raised to some exponent n, then that is equal to a sum to infinity from r equal to 0 of n choose r, then this is 1. So 1 to the power n minus r, which is the same as 1, times by ax all raised to r for all n in real numbers and and the absolute value of ax, or the magnitude of ax, is less than 1. And so this is it. This is how you state it. Phayana kwela phepha ndicela niyikope le nto. If yakohlula uyi-understand bese niyikreme, it's okay. Phela kulate now. Okay, now so this is it, but ayikakapheleli. Actually iphelele ne, but let's make it more simpler. Then this is equal to, then this sigma usixelele ubana ngaba this is nothing but a sum, and if we can notice, this is something that we have learned about on a binomial theorem, and we have proven it on the above upper screening. You can check apha kule kona ephezulu, then uzofumana apho bendiprova khona i-binomial theorem. Okay, now so let's say now r starts from 0, right? That means I just want to simplify this part here. So 1 plus ax to the power n is equal to n choose 0, then 1 to the power n minus 0, that's 1 to the power n, which is the same as 1, but I'm not going to write that one because 1 times a to the power all that is that, so this is simply going to be ax to the power r plus, okay, r, but r in this case, look at this, r in this case, r, this is my r, this is my r, so r is equal to 0. So here I'll have to the power 0, hopefully you understand. Then I'll have n choose 1, then here I will have some n choose 1, then this is nothing but 1, so I'll take this, I'll have ax to the power 1 plus n choose 2. So now if we can remember something, okay, n choose 2, then I take this ax to the power ax all raised to the power of r, but r in this case is equal to 2, plus I will list only the 4 terms because equation is of Huma ECT. List the first 4 terms of the binomial. This is what is state the binomial series. Then this is what you do. You state this. Then find the first 4 term. This I'm trying to compute here is that 4 terms. It's 1, 2, 3 so far. Okay. Then plus n choose 3 ax to the power 3 plus ... It goes up until forever because it goes to infinity. Remember that. But now remember that Remember, these properties, they are very important properties of a binomial theorem. N choose 0 is the same as 1. It's always the case. It's always the case that this is the case, okay? N choose 1 is equal to n. It's always the case. Then n choose r is equal to n factorial over r factorial n minus r factorial. Okay, now, so let's come here. N choose 0 is equals to 1. 1 times ax to the power 0 is the same as 1. So here we have 1, and it's always the case. Plus n choose 1 is the same as n. Here we have n x to the power 1 plus, but this is over 1 factorial. 1 factorial is the same as 1, right? Yeah. Then plus n choose 2. N choose 2 is the same as, now we're going to use this formula to compute n choose 2. That is the same as n factorial over r is 2 factorial n minus 2 factorial. Okay, so here I will have n factorial, then n factorial is the same as n times n minus 1, n minus 2, n minus 3, n minus 4 times dot 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 up until we reach some n minus minus n minus 1, which is this type, yeah, which is this. So this means that to compute this now, so n factorial, we're done with this one. N choose 2 is the same as, let's compute n choose 2 here. Let's compute n choose 2. N choose 2 is the same as n factorial over 2 factorial times n minus 2 factorial, which is the same as n times n minus 1 times n minus 2. But because this goes up until forever, upper, I will simply stop and say, okay, factorial, all divide by 2 factorial into n minus 2 factorial, because I want this n minus 2 factorial to divide this n minus 2 factorial. So this and this goes out, then I'll be left with n times n minus 1 all divided by 2 factorial. Therefore, here I will simply substitute n times n minus 1 all divided by 2 factorial. But remember, I have this ax all squared, so times ax all squared plus, then now I'm not going to compute this because I want to make this video as short as possible, but I'm sorry about that. But using the same procedure that we used to compute n choose 2, you can use it to compute n choose 3. So n choose 3 is the same as, n choose 3 has to be the same as n times n minus 1, n minus 2, all divided by 3 factorial times by ax to the power 3 plus dot dot dot. So if let's compute the first 5 terms, guess what would be the next term after this term? So now we have how many terms? We have 1, 2, 3, 4 terms. Therefore, we are done with this question. Let's go quickly to the next question.